All right, so for today we're talking about the scientific notation basics. This is a quick check. The first thing I wanted to put up here was just kind of a good visual because I'm going to be teaching you the rules on how to write things in scientific notation, but sometimes we don't really understand what we're doing or why we're doing it. So I really liked this visual aid. If you take 5,243, right now the decimal is back here. You can't see it because we don't put it there after the last number. But if we move that up one space, so times 10 to the first power, if we move it up two spaces, it'd be times 10 to the second power. And then if we move it up three spaces, it'd be times 10 to the third power. And the powers just tell you like how big the number's getting, or in other words, place value. So if you have 10 to the first power, that's 1 0, so that's 10. 10 to the second power has 2 zeros, that's 100. And we know this, 10 times 10 does equal 100. 10 to the third power, the exponent tells you there's 3 zeros, so that's 1,000. It keeps on going. Same thing for negative exponents. For negative exponents, we're still using the concept of zero, but it's going in front of the number, so it's making the number smaller. So you can kind of see that represented here. We're going to be using this idea for scientific notation. We're going to have times 10 to some power. Now we use scientific notation anytime we have numbers that are really, really big or really, really small. It's just a shorthand way of writing big numbers. So if we look at this first example, it says the area of Greenland is 950,000 square miles. What is this number in scientific notation? So here's the deal. In scientific notation, you always want your decimal after the first number. So in this case, I would want my decimal to end up, let me just write this bigger. I would want my decimal to end up right here. So I'm going to count how many times I have to move it to get it there. If you don't see a decimal in the original problem, it's always at the end. Anytime you don't see a decimal, it's hiding right there at the end. So if I want to count the spaces, I would go 1, 2, 3, 4, 5. Each hump is its own space. 1, 2, 3, 4, 5. So I'm moving that decimal 5 places. So when I go to write my answer, I'm just going to take the number part. I'm going to cross off the 0 part. So I'm going to write down 9.5 times 10. And we moved it 5 places, so it's to the 5th power times 10 to the 5. That would be our answer in scientific notation. All right, it says, what answer represents this number in scientific notation? I'm just going to write it bigger for my own sanity. Okay, so again, I want the decimal to end up after the first number that's not 0. So I want the decimal to end up there, so I'm going to just start where it started, and I'm going to count how many spaces I moved to get it there. So 1, 2, 3, 4, 5, 6. I moved this one 6 spaces. So when I rewrite it, I'm just going to write the number part. I'm going to cut off all the zeros. So I'm going to write 8.72 times 10. And since this is a really, really small number, we're going to do it times 10 to the negative 6. Now there's lots of rules for like if you move right or if you move left. The way I always think about it is if I'm dealing with a really big number, like 950,000, that's going to have a positive exponent. And if I'm dealing with a really small number, like 0.0000872, that's going to have a negative exponent. So usually that's the way I remember it, is I just ask myself, was it a big number or a small number? And that tells me whether my exponent will be positive or negative. All right, so what is this number in standard form? Okay, my exponent is an 8. It is a positive 8. So when I finish, I should have a big number. That's just good. I'm just going to make myself a little note of that. This should be a big number. So I'm going to start with 5.75, and I'm going to take my decimal and I'm going to move it 8 times. Now, I do not have memorized, I haven't memorized like right or left. So I'll show you both. First, I'm going to move it this way. 1, 2, 3, 4, 5, 6, 7, 8. So I move it 8 humps, and I'm not going to write the numbers out every time. I just want you to see that I moved it 8 times. This is where my new decimal is going to go. And then in every empty hump, I'm going to add a 0. So I could rewrite this as 5, 7, 5, 1, 2, 3, 4, 5, 6 zeros. And let me go ahead and put my commas in there. So 575 million. That is a really big number. So this is going to be my answer. Let's say that I had started with 5.75 and I couldn't remember which way to move it, so I moved my decimal 8 times this way. If you did that and then you double checked yourself and asked yourself, is this a really big number? No, that's a teeny tiny number. 0.000000575 is a teeny tiny number. So that would have represented a negative exponent, but we have a positive exponent. So you can always double check yourself by thinking about whether it's a big or small number. Okay, so we have 6.8 and well, let me write that down a little bit lower, and times 10 to the negative 5. So this time I do have a negative exponent, so I know that that's got to end up as a really small number. All right, so here I go. I'm going to take my decimal and I'm going to move it 5 places. 1, 2, 3, 4, 5. This is where my new decimal is going to be. And in every empty hump, or whatever you want to call it, I'm going to add a 0. So 0.00000068. That is a really small number. That is going to be the correct answer. But let me just go back and show you. If you accidentally moved it the other way, 1, 2, 3, 4, 5, and added in your zeros, this is a really big number. So you can self-check yourself and say, okay, I know that can't be true because it's negative. When you start to get the hang of this, you'll remember that every time you have a negative exponent, you're going to move it to the left. And every time you have a positive exponent, you're going to move it to the right. But sometimes you forget lefts and rights, so just think about whether it is going to be big or small. All right. In a recent year, the world production of wheat was about 6.2 times 10 to the 8th metric tons. What is this number in standard notation? So it's in scientific notation here, and I want to switch it to standard notation. My exponent is an 8. That is a positive number, so I should end up with a big answer. I'm going to start where my decimal is, and I'm going to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And in every empty hump, you're going to add a 0, and then you're going to rewrite it. Ooh, that's a lot. So then we put our commas in, and it's 620 million metric tons. All right, which statement is true? So we're given this number 9.503 times 10 to the negative 3rd. Now remember that negative exponent tells us we want to be smaller. We want to make it a small number. So if I just, before I even look at my answer choices, if I just think about solving this, I'm going to start wherever my decimal is, and I'm going to move it 3 times while making it smaller. So if I write this correctly in standard notation, it should look like this. And you can do that to help with process of elimination. Like here, they moved it and added 3 zeros on the end. That's not right. For this one, they moved the decimal 3 times to make the number bigger. 9,503 is a big number. We have a negative exponent. We want it to be a small number. So we're down to kind of these 2 answers. But when we did it correctly, we moved our decimal 3 times. So it ended up like this. What they did here is they added 3 zeros in front. You're not just adding 3 zeros for an exponent of 3. You're moving the decimal 3 places. So that's a really common mistake. Don't think that you can just look at the exponent and add that many zeros. You need to count how many spaces you move the decimal. And they said because the exponent -3 means that you are dividing by 1,000. And that's referring back to this very first chart that I put up here. When you have an exponent of -3, you are dividing by 1,000. Let me see. Yep, that was it. So I hope this helps. Good luck on scientific notation.